Hello, today I'm going to show you my first version of the project, which is connecting Arduino board to Android to play a mobile game, first version. The goal of the project is to connect the Arduino board with Android through UART service and give gyro data by Bluetooth connection. By meaning of giving gyro data, this means that when the Arduino boards gets updated constantly, when its state changes, the data will be given to the Arduino board, the main board, and it will constantly update the data. And second, it will play mobile Android game from Arduino board's gyro data. The thing I mentioned before, the gyro data will be given to the Android, and the Android will modify the data as the controller's coordinates to constantly update the player's character. The materials you need are as follows: Arduino board, Adafruit Feather MO, which is going to calculate the gyro data, and the MPU 9265 sensor, which is going to send the gyro data to the Arduino board. You can use either MPU 9250 because they all work in the similar way. And finally, you need the Android platform to run the program. The key functions in Arduino, the first thing to mention is to connect the Arduino and Android with UART connection. If the factory reset can be doable, it will do the factory reset and it will show the information of the Adafruit board on the serial monitor, and as it is finished, it will make the device ready for the connection. Now, as it is connected, the Android and the Arduino is connected together. Now, the Arduino board should receive the gyro data from the sensor MPU 9265, and the sensor will calculate the coordinates and try to send it to the Arduino mainboard. So first, we should calibrate the sensor so that it should give the status change in that condition, and after that it will start to calculate the 3D coordinates like yaw, pitch, and roll, and it will show up a line of statement that it is ready for calculation, and as in the void loop, it will calculate the accelerator data, gyro data, and magnitude data to calculate the overall yaw, pitch, roll. As you can see from as it is continued from the previous slide, we can see that the magnitude, accelerator data, and the gyro data is being calculated, and it is sent to the Quaternion value, which is the library that I used when I used to calculate the yaw, pitch, roll. So the Quaternion is related to the Euler angle, so I'll leave a link down below to show you what is the Euler angle and how it is calculated. As we are done with the calculation, now we should send the data through the Bluetooth connection into the Android. As you can see, it shows that in the serial monitor we can see the yaw, pitch, roll data as we printed in the serial monitor, and at the other side I have cleared as the BLE, which is the Android Adafruit board, is going to print the yaw, pitch, roll data to the Android as it says ble.print. The bars are marked is to categorize the data so that it doesn't confuse the user or the platform. Now, in the Android, we have to connect the Android and the Adafruit from the Android's perspective. So I created a class called BLE Manager, which manages the connection between two devices, and I made a boolean called connect, which is to see if the device is ready to connect with the Arduino board. And as the down below, so it is when it is in connected, when it is able to connect to the other device, it shows that it is going to do various methods to get the device ready for it. As the precondition is already done, now we can make the two devices connect each other by getting the remote device's address and putting it inside the M device. And so as it returns true, this means that they are all connected and it is ready to do the game. Because we are using the data from the Adafruit board, we have to use the data sent from the Adafruit and try to receive it. So I put the code called update text data UI, which shows that it is going to update the data given from the Adafruit board so that it is updated constantly to make the play more fluent when the user is playing the game. As you see down below, it shows that how the data is added, and this helper method add text to spam buffer shows that it is going to accumulate the data given from the Adafruit board so that the game doesn't break much. Now we have to modify the data given from the Adafruit board to divide it into yaw pitch roll. Since the data has too many decimal points, I had to hard code it as how many decimal points it has for each value. I'll have to fix this code by reducing the decimal points, which seems unnecessary, or by some other methods to figure out how to make the program more fluent and extensible. Now this is the game, one of the methods in the game class, which shows that I get the data from the UART, which is the yaw pitch roll, and as I put it inside the main character's X and Y coordinates, I'll put it as the roll pitch as follows, and if the Adafruit board now changes its state, it's going to calculate the data given from the Adafruit board and try to put it inside the main character's coordinates. Now, as I try to connect the Adafruit board and the Android phone with this connect button, there are several choices I can make when they are all connected together, but since we are going to play the game, I'm going to choose Titanic, which is the game's name, and the blue light is on in the Adafruit board, which means they are all connected and we are able to play the game. As I start the game, this board becomes now the controller, and we can control to save people from the Titanic accident. Since the coordinates need to be justified a bit more, modified a bit more, I'm working on those. Like this error comes up because the values given from the Adafruit board is not really usable, so I need to make some exceptions for data, like trash data like this, so I can make the game don't crash when you're playing the game, when the user is playing the game. So this is all I have for today, and thanks for watching the video.